Hello everyone. Today we talk about decision trees. Decision trees form the basis of several machine learning algorithms that can be used to predict certain outcomes. But before delving into how decision trees can be used as machine learning algorithms, let's first look at how decision trees work in its basic form. As the name suggests, you can use decision trees to make several different types of decisions. For example, you're in a market and you are trying to buy mangoes. Um, Naturally, what humans look at are certain distinguishing characteristics of a mango before buying them, or any kind of fruit, right? So, for example, uh, you would maybe look at a mango's color and take a decision according to what the color of the mango is. So for example, if the mango is orangish, then you take a certain type of decision. And if it's greenish, then you take a different type of decision, right? For example, the mango is the color of the mango is orange. Then you would maybe take the mango in your hand and look if how soft it is. So you would look at its softness, right? So if it's hard, then you might decide not to buy the mango. But if it is mushy or soft enough, then you might decide to buy the mango because the color is orangish, looks good, and it also feels good. It's not too hard or too mushy, right? On the other hand, if the color of the mango is green, you'd not maybe disregard it totally by just looking at its color. You might want to look, uh, take it in your hand and look how soft it is, right? Then you check how soft it is. If it's too hard, if it's just hard, then you might decide to buy it even though it's hard and green, because you might think that it will ripen as time goes by and you might be able to eat it in the next 3 to 4 days or maybe in a week. But if it's too mushy, like too soft, then you might decide that it has rotten or something, and you might decide not to buy. So this is just a hypothetical example uh, of how we might use decision trees in our daily lives to take certain decisions. Now, let's look at another example. Let's say we're trying to decide if we want to buy a dress or not. We're in this shopping mall and we're trying to decide that, okay? So one might look at the color of the dress, right? Um, and let's say there are 3 color dress options, green, red, and blue. So for example, just a hypothetical example, let's say that if the color of the dress is green, the person looks at the size of the dress. If it's big, then he or she decides not to buy the dress. If it's small, then he or she might decide to buy the dress. Maybe for his or her kid or something. Okay. Next up, we see that if the color of the dress is red, then he or she decides to buy the dress without looking at any other attribute of the dress like size or shape. Now, using this decision tree, we might decide to tabulate our results. For example, if we look at this leftmost branch, we see that the color is green. So we enter green in the color column. Size is big, and it doesn't matter what shape it is because we don't look at the shape in the leftmost branch. So it can be round or square, and we decide not to buy it, right? Right. Okay. So for the next branch, we can see that again the color is green. Size is small, and shape does not matter. So let's say it's square, and the decision is that we want to buy it. Similarly, we can add another row to this table. For example, color is red, and it does not matter what shape or size it is. So let's say that the size is big, shape is round, and we decide to buy it. So like this, we can formulate or tabulate the different results of the decision tree in a table. Since it does not matter what size or shape it is, if the color is red, we can add another row, for example, like color is red, size is maybe small this time, shape is square, and still we would want to buy it, right? So as you can see, we can represent this decision tree in the form of a table, like on the right hand side. Similarly, we can also represent a table like this as a decision tree. For example, if we have a truth table like this, we can draw a decision tree from it. How? We can see that in the first row, CGPA is less than 3.8. So let's say CGPA is our first attribute. So on the left hand side, we keep the less than 3.8 value. The right hand side, it's the greater one. Okay. After looking at the CGPA, we look at the GRE score in order to make the admission decision if a student should be admitted to a university or not. Okay, so we see that GRE score is greater than 330. So the decision is yes, we can admit the student. For the second row, we see again that the CGPA is less than 3.8, but this time the GRE score is less than 330, right? So the decision is that we cannot admit the student. And the last row, we can see that CGPA is greater than 3.8. So we go to the right hand branch from the top. And in the next level of the decision tree, we check the GRE score again. We see that GRE score is greater than 330. So we choose to admit the student. Okay. Now that we have seen how a decision tree can be formed from a data set or a truth table, such as this on the right hand side, let's get familiarized with some of the terminologies. So we see that in the data set, we have certain attributes. These are the attributes: color, size, and shape. We also have a decision, whether we want to buy a dress or not, or we want to admit a student to the university or not, and so on. In the data set, we also have certain examples. So each of the row in the data set is one example, right? And in each example, there is a value for each of the attributes. So for example, in example 1, the value for the attribute color is green. In example 1, the value for size is big, value for shape is round, and the decision is small. In example 2, again the color attribute has value green, size attribute has value small, shape attribute has square, and the decision is yes. On the other hand, in the decision tree, we can see that there are some non-leaf nodes. These non-leaf nodes actually form some tests. We perform tests according to the attributes in the dataset. So for example, color is one of the non-leaf nodes, right? So we form a test that what is the color of the dress? Is it green, red, or blue? So we can also observe that each of the non-leaf nodes has a specific number of branches, and the number of branches depend on the number of classes the attribute has. So for example, this color attribute has 3 types of values, right? Green, red, and blue. So it has 3 corresponding branches. So for the first branch, the test is the color. What is the color? It's green. So we move to the leftmost branch, right? Similarly, for the size attribute, which is again a non-leaf node, we have 2 branches corresponding to the 2 types of values that the size attribute has, big and small. Again, shape has 2 values, which are square and round, so it has 2 branches coming out of the non-leaf node. Lastly, there are the leaf nodes, which actually contains the decisions that the decision tree has made. So for example, this is a leaf node, this is a leaf node, and these contain the decisions or the labels that has been formed based on the values of the attributes in the dataset. Now that we are familiar with the basics of a decision tree, let's look at how decision trees can be used in machine learning. So in machine learning, usually we have a big data set, which is at first divided into a training set and a test set, as you can see in the diagram on the left-hand side. Using the training set, we usually train the learning algorithm, in our case, which is the decision tree learning algorithm. And using the test set, we usually test the quality of the learned algorithm or the learned model. So using the training set and a suitable learning algorithm, for example, examples of decision tree learning algorithms can be ID3, C4.5, or classification and regression trees, which we will be looking at in detail in the subsequent videos. So using a learning algorithm and the training set, a model is learned at first, and this model is then applied on the unseen examples in the test set to measure the quality or the accuracy of the learned model. As you can see in the test set, the class of each of the examples are unknown, noted with a question mark, right? So our objective will be using the learned decision tree model and to predict the labels of these examples. So we'll look at the details of learning a decision tree or forming a decision tree in the subsequent videos. But before that, let's look at what happens after learning the tree. So let's say we have a decision tree, such as on the right hand side. Now, after encountering a unknown example from the test data, such as this, let's see what happens. At first, the learning algorithm looks at the root of the tree. For example, the objective is to determine if a person will cheat or not. Okay? So the learning algorithm looks at the root of the tree and performs a test. Right? We can see in the test data that the refund value is no. So the learning algorithm goes to the right branch. Next, it performs another test, which is the marital status. In the example, the marital status is married, so it again goes to the right branch. And then it encounters the label of the example, which is no, that the person will not cheat. So the learning algorithm assigns the label of this particular example to be no. And this is how we can predict the label of unknown records using a decision tree.